Good morning, everyone. Glad to see such a big crowd on the last day of the Dev Summit after the party. I was not really expecting that, so thank you all for coming. So we have a lot of things to go over today. I'm going to give you a pretty broad overview of the entire Utility Network SDK. I'm going to start with some introductory material, and then we're going to do a 10,000-foot survey of all the major areas of classes and methods and give you a good starting point. I'll conclude by pointing out a couple of gotchas in Pro 2.1 and a little bit about the plans for Pro 2.2. And then finally, to wrap it up, I'm going to kind of give you a survey of all of the documentation that is out there. Sound good? Sound good? Don't make me be that guy, okay? All right. So if you learn nothing else from this talk, learn this. This is how you get to the home page of the SDK help. You can either remember the URL, or you could just type ArcGIS Pro SDK into Google or your favorite search engine of choice. So just a quick overview. The Utility Network SDK, it's a C# SDK that provides access to the utility network. It is an object-oriented API that aligns with modern C# practices and existing frameworks. So it kind of fits in with the rest of the Pro SDK and with the rest of the C# user community. Now, unfortunately, this presentation assumes you have some basic understanding of the utility network information model. Unfortunately, due to a little scheduling snafu, that utility network information model will be fully explained at 10 a.m. this morning. I know. All right, couple quick architectural topics. First, it's worth noting that with the rest of the Geodatabase API, the utility network APIs are DML-only, so data manipulation language, right? Anything that creates or modifies schema is accomplished through Python, through geoprocessing tools. So there are routines you can get to see the schema and examine the schema using C#, but changing it requires going out to Python. Now, this doesn't mean you need to really learn a new language or anything like that. You can still call geoprocessing tools from C# using the geoprocessing API. So this particular set of 2 lines just tells you how to import a set of rules from a file. Who here is familiar with or an expert in ArcObjects programming using COM? Show your hands. All right. So for all of you people, if you haven't done Pro SDK programming before, this is going to be probably the biggest barrier to overcome. Pro is a multi-threaded application. There's lots of user interface threads. There's presumably internal threads. And there is a thing called the main sim thread. Also usually abbreviated MCT. For those in the electric industry, SIM stands for Cartographic Information Model. This is an Esri abbreviation, not to be confused with the SIM, that's a Common Information Model used for electric distribution and transmission utilities. So anyway, the idea behind this is that you have to create these tasks using this queuedtask.run method, and you put all of your utility network, actually all of your geodatabase code in there. So if you have an add-in that gets input from the screen, works with layers, that all goes in your UI thread, and then you make a geodatabase call, you put it in the geodatabase thread, and you often shift back and forth between the different threads. So you don't put up a message box in there, and you don't call utility network code outside of there. There is, so you'll be getting these slides as part of the proceedings, but there's a link to the Working with Multi-Threading document to give you some more information. So just be aware that that learning curve will trip you up for a few days at least. I'd be remiss if I didn't mention that there's other ways to access the utility network through code. First of all, you can use geoprocessing models and Python scripts. There may be times when you can solve the problem faster and easier without needing to bring up Visual Studio. And finally, you can directly code against the REST APIs. If you're an experienced REST developer, all those REST APIs are there. Certainly do not recommend doing that from inside Pro, because anything you do through these direct calls, the rest of the application isn't going to know anything about it. So things like screen redraws and stuff like that won't happen. All right. So I think it's easier to understand the API if you break it down into some pieces. So I've kind of broken it down into these 9 different sections. This is not a layered architecture per se, but it is kind of a collection of classes that do sort of build upon each other in some sense. And we're going to start with the utility network class. The utility network class is the root object that provides access to the rest of the SDK, the rest of the APIs. So it is the central hub. And you're going to hear me mention this class 24 times for the rest of the morning. A couple different ways you can get to it. You can get to it from a geodatabase, from a feature class, or from a layer. But rather than having you look through all that code, I think we're going to have Dave show us how to do this.
Hi, everybody. Excuse me. I apologize. I have a very dry throat today. So as Rich said, there's many ways to access the utility network. If you're in a map, I can just select it. But for the purposes of this, we're obviously going to show you how to get to it from code. I'm going to show you 3 different ways to access it. I've buried it all behind this button just so I can get into my IDE. So what we're looking at here is there are 3 ways that I can open the utility network. I can open it from the geodatabase itself. I could open it from a subtype layer, or I could open it from the utility network layer. So let's walk through each of those 3 just to see sort of the process by which we open these things. So if I step into this method, what we do is we can go in, and because it is multi-threaded, you'll notice I just bounced around there a little bit. It's just because the queued task event is waiting on things. So we can connect to a geodatabase directly by hitting the REST endpoint. We construct that using a URI and a service connection properties. It's very analogous to the way we used to connect to geodatabases using SDE connection files, except because we are a services-based architecture, you go to the feature server, and that is your geodatabase as far as our SDK is concerned. So when I step over that, I actually now have a reference to the geodatabase. Now, this was published with the default version, so this geodatabase is pointed at that version. Now, I'm not going to step into this for this demo, but the utility network is fully version supported as long as you have your version management service enabled when you publish. And so we do support creating versions in this SDK. The way you do that is off the geodatabase object, in this case the default version. You can get the version manager, describe a version that you want to create. So in this case, something called my version with a little description and access. Now this type can be public, protected, or private, the same as our old traditional versions. And then you just call out to the version manager and say create version. Provided that description, that returns back to you a version object, which you can then call connect on, which will return a geodatabase reference to that child version. You could then use that geodatabase to open the utility network, as I'm about to do in the next line. But again, I'm using the default version. But had my geodatabase now pointed to that child version, the utility network that's open would be on that child version. So I can step over this line. And the way that I grab, because it is services, we could just attempt to call open data set with the utility network. However, the name of the utility network is not the most straightforward thing when it is in a service, because we append the layer ID and a letter L to the front of it, which is necessary to open. So the way that we get around that is we ask for all of the definitions of utility networks that live in that service. In my case, there's only one of them. So off of that definition, I can call the method getName, which is going to give me that proper name. And I'll show it to you in just a second once I get this object. And it will give you that proper name so that you can call open data set against that geodatabase, and it will be successful. So I grab that utility network, I return it out. And now in here, we can actually see what that name looks like, as I was describing if I hover over this guy. I'm not sure how readable that is, but let me see if I can. I can't really zoom into that. But you'll see here it says L13 electric underscore utility underscore network. Trying to remember what that name is gets a little bit tricky, which is why we use these definition objects in order to manipulate our way around and make sure we're opening what we expect to open. The next way to open it is a little bit easier. Now this is a ArcGIS Pro centric way of opening it. It requires layers in a map in order to get to them. So in this case, I'm going to go to a subtype layer, which is the new concept introduced with ArcGIS Pro 2.1 or 2.0, where one layer refers to a feature class, and each of its sublayers is each of the subtypes in that feature class. So in this case, I can check if the layers I'm looking at in my map are a subtype group layer. If they are, then I can grab the first feature layer out of it. I know that under the hood, the subtype net layer only refers to one feature class, one table in my database. So I can cheat a little bit here and just grab the first layer out of there, knowing that the reference will be true no matter which layer I pull off of. I can then set some variables that I'm going to populate here. Now, I have to go into my QTask.run because I'm going to be executing things directly against the geodatabase, such as getTable. All of those are required to be executed on the main sim thread, as Rich was describing, which is why I have to bury them inside of a queued task event. If you were to, when you program against this, the IDE will help you. It will tell you when you type getTable in the help, it will say must be executed on the MCT, which means putting it inside of one of those QTask.run events. Now, off of the layer table which I get, this is just the feature class, the table in the database. And I pull that right off the feature layer, which is part of the subtype group layer. I can ask it if it supports a controller datasets. Now, controller datasets are what we refer to as any dataset that controls other classes. The network dataset, topology, geometric network, utility network are all different controller datasets. In this case, the table I'm looking at only has one. So when I get those controller datasets, I know there's only one in here. Now I can still type check it, because it is C#, so it is a strongly typed language. I can still type check that it is a utility network. If it is, I simply convert that dataset with an inline cast to a utility network, and then return that object back out to the caller. We get it, and then we can see that in here, it's the same utility network. I used a different variable name so that I could prove that I actually opened it there and I didn't open it previously, and cheating you guys out. And then we can walk through. And the last way to do it is directly from the utility network layer. This is probably the easiest way to access it if you're directly in Pro, because as you'll see when I go in here, all I do is check if my layer is a utility network layer. So in this case, I loop through all the layers in my map. I find the one that is the utility network layer. And then on that layer itself, there is a getUtilityNetwork method, which returns back that utility network. Now, in that first example I gave, opening the geodatabase directly, I could have connected to a version. These layers are driven by the version that you've specified in the map that you're working off of. So if that map was pointing at a version other than default, this utility network reference would be to that version of the utility network. And those are the three fun ways to access our utility network.
Okay, we're back to microphone. So next section I want to talk about are definition and schema. So there are a collection of classes that you can use to basically query the schema of your utility network. So Dave already showed us the utility network definition class, which you can get from either the geodatabase itself or from the utility network. Underneath that, you'll see domain networks. For each domain network, there's a set of tiers. Utility networks also contain network sources. Network source, probably worth pointing out what a network source is. This is a network source that provides data to build your index, to build your network. This is not to be confused with circuit breakers or regulator stations or anything like that. This is actually, in almost all cases, a feature class. So it's the input of rows into the network topology. Every network source contains a set of asset groups. You guys, if you're familiar with the model, if not, you'll get it at 10. Essentially, asset groups correspond to subtypes, and then asset types, which is that second level of discrimination. Utility network definition also includes a list of all your network attributes. These are database attributes that are added into the network topology for fast traversal and access. And then we have terminal configurations and terminals, of course, rules and rule elements. So I could go through and list out all the methods and properties on each of these objects, but it frankly isn't very interesting and it would take the rest of our time. So you can go check those out in the API reference. Important thing to note though, these are read-only access, like I mentioned, so you can't make any changes. And finally, they are value objects that are derived from information cached with the feature service. So calling any of the routines in this section, any of these classes, is not going to generate a round trip to the service. So they're pretty fast. Next, I want to talk about element. An element is a class that you will see throughout the API. It represents a row inside the utility network plus a terminal if applicable. So I'll come back to what that means in a minute. So you use these to create and delete associations. You use them to specify starting points and barriers. You also get them back from the API as results from trace. So when I say it is a row plus a terminal if applicable, when you're doing a trace, you can start a trace at a switch, or you could start it at a specific terminal on a device. Like I want to do a downstream trace from the low side of a distribution transformer. Likewise, when you get back results from traces, you may get back multiple elements for a single feature. So if you were doing an upstream trace from a service point, you're going to get, so again, using an electrical example, you'll get back the low side of the transformer, the high side of the transformer, and the edge that's between them, in addition to all the other features on your way upstream. Important thing is these are created using the create element method on the utility network class. Okay, network topology. We have a set of routines that query the topological index. Now, the network topology, the network index, if you want to call it that, stores the connectivity, containment, and structural attachment information that is used to do fast network traversal and retrieval. So this index itself is created from a number of things. It's created from your geometric coincidence. It's created by your associations that you've defined in combination with the rules engine. So if two things are spatially coincident, but there's no rule to connect them, then they're not connected in the network topology. There's a routine called validate network topology on the utility network class that validates that and clears out your dirty areas. Important thing to note, we do not provide access to fine-grained topology. What I mean by that is if you're a geometric network programmer, you may be familiar with iForward star. iForward star, allow you to start at a vertex and go to the edge, and then go to the vertex and go to the edge and go to the vertex and step your way through the network. If each of those steps was a call to the feature service, you would be waiting a very long time to do these sorts of things. So we're not permitting that fine-grained access. Instead, we're providing a highly configurable tracing framework, which we'll talk about in a few minutes. Associations. Hopefully you've stopped by the booth or heard about this stuff before. There's three kinds of associations. Connectivity associations, which is used to connect 2 points that are not coincident. Containment, so a transformer contains a transformer unit and a fuse, and then structural attachment, like a transformer attached to a pole. So given a particular element, you can query for those associations, and you can also create or delete associations. All of those routines are on the utility network core class. Subnetworks. So subnetworks, basically used for circuits in electric, used for things like pressure zones and isolation zones in water and gas networks. Subnetwork Manager is kind of the key class that wraps up all the subnetwork management routines. The Subnetwork Manager class comes from, you guessed it, the Utility Network Core class. There's a number of methods on here that allow you to query what subnetworks are available, and routines to enable controllers and disable controllers, which the first controller in a subnetwork will create the subnetwork, and then you can, the last controller that's disabled on a subnetwork will delete the subnetwork. Again, you'll be covering through these concepts in the next hour. The subnetwork class itself just provides a collection of information about the subnetwork, allows you to do update, which is pretty useful. You can get its state. You can get the network diagrams that are associated with that subnetwork, and you can, this is an interesting one, get the line feature. So if there is a subnet line feature that corresponds to that subnetwork, you can fetch it here in one call. Tracing. I assume everybody in this room knows what tracing is, so I will skip that little section there. So there are a lot of different objects that come into play when you're building a trace. The different traces themselves are implemented with tracer objects. So we provide, well, actually, I'll go ahead to that later. Input to that tracer object is encapsulated by a trace argument. That includes the starting points, barriers, result types, and trace configuration. The output out from a tracer is you get a set of result objects. So we're going to go through each of these parts in more detail. So the tracer itself defines which tracing algorithm you're going to be using. Tracer objects are created using a trace manager. The trace manager comes from the Utility Network Core class. As I was starting to say, we provide a different tracer class for each of the different types of traces supported by the utility network. So if you go up and look at the ribbon, you'll see basically traces that correspond to each of these classes. Trace argument, this is your starting points, barriers, result types, and then trace configuration. So trace configuration is where most of the interesting thing takes place. So this is, again, the sort of thing where you could talk about this for half an hour, but instead what I'm going to do is I'm going to match this up to the user interface. So when you're coding a trace, it's very helpful to have Pro alongside you. Do the trace using the user interface, and then you can see how the different parameters in this geoprocessing tool correspond to the methods and classes in the API. So hopefully you guys all saw the tracing geoprocessing demo that Rick and Tom did yesterday. So those were the basic properties, like include structures and so forth. Traversability. Traversability is based on barriers. So this is all written as kind of a negative things, maybe the opposite of what you're thinking of. So you're comparing against network attributes, or you're checking for the existence of a category. So if you're trying to do a trace along plastic pipe, you're going to say, you're going to create a traversability condition barrier where material doesn't equal plastic. So it's a little bit opposite what you might think, because it's defining the way where you stop, not how you continue. You can also combine these expressions using and or. So you can get some pretty complex, expressions that you can come up with there. We also have the ability to stop based on a function calculation. So you can say, I want to set a barrier where my sum of shape length equals 1,000. What that will do is that will trace out 1,000 meters from every point, from every direction from the point where you started, or 1,000 feet. Functions themselves, these are the functions that are calculated while the trace is executing. So you can create a whole bunch of these and look at the results afterwards. So you can say, I want to sum up the count of customers on a downstream trace. Another example is you want to sum up the sum up the length of conductor or length of pipe in this circuit, in this trace. Filters. Filters are a very interesting thing. These allow you to stop tracing when returning results, but they don't stop traversability to the controller. So let me explain what I mean by that. Let's say you wanted to do a trace where you wanted to find your next upstream protective device, or maybe this is your next upstream valve or something like that. If you set up a traversability filter that says stop when you find the next protective device, your trace is never going to find the subnetwork controller. It's never going to find the circuit source. So it's going to stop and it's going to say, I don't know which way upstream is. I can't find the source. So what you do is you put that in a filter, not in the traversability. Okay? Lots of different ways to define filters. You can use a condition based on network attributes. You just saw that on the last slide. You can use a functional expression. You can use what's called a bit set filter. And a bit set filter allows you to trace on a particular phase. If you have on a particular value of a network attribute that is built from a bit set. How's that for good computer science terminology there? So most people would implement phase as a bit set where phase A equals 1 and phase B is the second bit and phase C is the third bit or something like that. You can also use what's called the nearest neighbor filter to return the next three things or the closest three things. And finally, we have output. And output allows you to filter the results after everything is done. So it takes place after traversability, filtering, and function calculation. And you can filter by a output condition or by an asset type. So one thing I mentioned is it's good to have pro user experience up, and you can do these traces, and then you can see, match match the settings up to the code in the API. Another thing you can do if you're familiar with the product Fiddler, Fiddler listens to all the web requests that take place. So what I found very useful is I run this tool from the user interface using Fiddler. I look at the call that is made to the service, and then I run what I think is the same code from C#. And I again look at Fiddler, and if they don't match, then I know I need to do more work to get my code matching the UI. Great way to find bugs and find out you're using an and instead of an or something like that. Propagators. Propagators are an advanced concept. It's sufficiently advanced that we don't make it easily accessible through the user interface. You can get to it through geoprocessing, and you can get to it through Python or from code. So what a propagator does is it takes a network attribute starting at your source, starting at your, subnetwork controller, which would be a circuit source or a gas power source, and does a traversal, and you want to propagate that value down the network. So they only work with subnetwork-based traces. So some examples of this would be phase propagation or voltage or pressure. So every time if you start at a high pressure pipe, as you go down the system, you're going to get to lower and lower pressure areas. So what you can do is you can do things like at a pressure regulator, you can say what the pressure will be downstream, and then that value will be propagated downstream. So propagator values are computed as a pre-processed step before the main trace takes place. So what that means is that, I'm going to go back to the phase example. If you start at ABC, it's going to do basically a subnetwork trace, and it's going to calculate the phase at each point along that traversal. So if it finds a switch that is open on one phase, that phase will stop propagating from that point down. So the system then has that value for each element, and then it goes through and does the trace itself. Because what you can do is you can have the trace itself stop when it hits a certain condition. So what that's used for, primarily is things like if you're doing a phase trace and you want to open phase A on one switch, you don't need to go down and manually edit everything downstream of that to change the phase, to change the normal phase. Instead, we'll use that propagator to say, okay, right now, because that switch is open, A phase doesn't go past that switch. Trace results. You get back a set of result objects. So you might remember that as one of the inputs to trace argument, there's a result types collection. You pass in a set of enums saying what kind of results you want. So right now we support two kinds. We support element results, and an element result returns a list of elements. So if you're doing a connected trace, this is going to return a whole bunch of features that are connected to your starting point. Again, worth pointing out that this list of elements, if there are any devices with terminals in your trace results, you're going to get back multiple elements for each of those features. Second kind of result object is a function output result. This is going to return a list of all of your functions that you passed in and the list of values that it returned back. So if you guys remember the plenary demo on this, we had a trace that returned the sum and count of customers. This would be part of a function result. Now in the future, we may implement additional result types. So some of the things we're talking about, returning a network diagram, maybe returning a geometry of your trace result rather than a bunch of features, returning propagated values per row, lots of different possibilities there for the future. But none of this is scheduled or mapped out or anything like that. The good thing is the way that the tracing API is set up, when we do add these new trace types, all we're going to do is we're going to add a new enum and then a new concrete class for result. So you won't have to change your code and we won't have to change our interfaces. All right, I know that was kind of a whirlwind tour. That is how traces are built using the API. Network diagrams. So network diagrams, this is the roughly equivalent to the old ArcGIS schematics functionality that used to be an ArcMap. Network diagrams are included with the utility network. As a first-class citizen, we provide a full API to get to them. There's a Diagram Manager class. Guess where the Diagram Manager class comes from? Good, you all got it, or at least you're laughing. One of the two. So yes, it is the utility network object. There's a method on there called getDiagramManager. So basically this collects all of the core methods and classes for diagrams. So you can use this to create diagrams, retrieve templates, retrieve diagrams, get the network, all sorts of things like that. I will not go through every method on the network diagram class. It would take too long, but suffice it to say you can look at all the different properties on there. You can also update, append, and overwrite the diagram. The difference, by the way, between these three is updates the diagram based on any recent changes made to the features. Append allows you to add additional features to the diagram. And overwrite allows you to take the diagram and completely replace the features that are in there, but use all the other properties. Of course, store and delete makes sense. One of the key parts of getting a network diagram is you can get the actual elements that are in the diagram. So these are the little lines and points you see in that schematic view. So there's different kinds of diagram elements. You can see containers, junctions, and edges. Curiously, you can get to the junctions from the edges when you get that. So you can actually build somewhat of a rough topology from a diagram itself. There's a number of different routines to get diagrams. You can get it by type. You can get it by extent. So you can say, I want this part of the diagram. Give me all of the elements. You can get a set of object IDs. And there's a whole set of classes and methods to do that. So why would you want to do that? Just one example is if you wanted to create a custom layout algorithm. So the way you would do that using the SDK is you'd query for a set of diagram elements. Then you go into those elements, and I don't know if you noticed, but there is a shape property right there. So you can change the shape of each element. Then you create a network diagram subset, and you pass that into the save layout method, and now you have a new custom algorithm for generating your schematic. All right, let's take a quick look and see how those look in code.
All right, so everyone can see my map here. I'm zoomed into an area of our network that I'm interested in. Now, in here, I've already generated a diagram. This diagram is a geoschematic, so you sort of look at it and go, okay, what if I wanted to change that layout algorithm, though? Now, there is a lot of tools, obviously, provided within the Pro interface itself. But if I wanted to do it through code, how might I go about doing that? So I can go in here to my add-in world and say I want to change that layout. So what I can do is I can start by opening the utility network. Now, again, I could have opened it any of those 3 ways I had shown before. In my case, I just realized I did that wrong, but that's okay. So I can open my utility network, get it returned, and then from the utility network object, as Rich has so eloquently informed us many, many times, we find everything of use to the utility network. So in this case, we find our diagram manager. And the diagram manager is the thing that lets us go and find templates that exist in our data. They allow us to find existing diagrams, do some of the work with all of the diagrams themselves. So in this case, I'm going to grab a diagram template that I'm interested in. I don't actually use it. I just grab it, for fun. But now I can look at my diagram manager and I can go and pull all the diagrams that I have available to me. Now in this case, I'm looking for that one specific diagram that I was looking at, which in my case I had called not a smart tree diagram. And the reason I called it that is because I'm going to update it. The way I'm going to do that is once I have the diagram itself, I can create a diagram layout parameter. And in this case, I'm going to create it using a smart tree diagram layout. By taking that layout and applying it to the existing diagram, it will flash my screen. And then it will apply. And now I have choices. I can either just leave it where it is, and the existing diagram has that algorithm applied to it. Or, in my case, I'm actually going to take that diagram and store it with a new name. And in this case, I'm going to call it the smart tree diagram. I made it public. You can also make these things private. And then you give it a little description. So then I can return back in. And so now what we see is if I refresh my find diagrams, and the way you get to this find diagrams pane is from the utility network tab itself. In our diagram section, I can click this the find diagrams button. It launches this pane. Now by default, this cover parts of the active map extent is turned on, so it limits the amount of diagrams that you look at. I turned it off just because I wanted to be able to see all of the diagrams in my network. And if I now refresh that list, go to the last page of it, you'll see that now that not a smart tree diagram 2 has gone away. I now have this smart tree diagram. So if I open it up, what we'll see as it takes its time to open up, so we're just going to have a little talk with each other as that happens. You're going to see that that diagram has had the algorithm applied to it. It's a left to right smart tree. And it's just a basic thing. I haven't done anything custom to it. I could have added a lot of I could have moved some of these things around. I see that I have some junctions up here that are in an odd spot. So I could go and identify their elements and I could move them around. What I'm going to do though is I know that in this particular diagram, I don't like what the root node here is, the very first node that drives the diagram. If I look at it, I can see that its element ID is 1. But I actually want element ID 35, which is right here, to be my root. So the way I could do that update is, if I go into my other little add-in here, I can again open my utility network. And this time I'm going to put a breakpoint there so I can jump right out of it. I open my utility network. I again get my diagram manager. I can go and find that specific diagram from the list of all diagrams. So find that smart tree diagram I just created. Find my algorithm that I'm going to apply to it. Again, I'm just going to use the smart tree. I can change the root node by using this add flag method, which exists on a current diagram. So I have my diagram to update. I'm going to add a flag. In this case, I'm going to set it as the root junction. There are other types here besides root junction that you can use that will help you manipulate your diagram. And I know that element ID 35 is what I'm interested in. I can take that, add that flag to the diagram, apply that algorithm to it, and now, when it comes back, and I refresh this again, we now open this guy up. And when it opens, I'll identify the leftmost junction. You'll see that it has been updated to use that element ID of 35. If I zoom out a touch, or there it goes. So you can see that as it refreshes now, it's still a smart tree, but it has changed slightly. And the very first root node now is that element ID of 35. So these are obviously some pretty basic examples of how to manipulate these diagrams. But as Rich said, you get access to each of these elements by querying them within a single diagram, which then allows you to manipulate it at a more fine-grained level. Back to you.
All right, we're in the home stretch. There are finally a number of different pieces that allow us to integrate the Utility Network API with the rest of the Pro SDK. Everything we've been talking about so far is down at a very low level at the database level. How does that work with the rest of Pro? Dave actually mentioned this originally, but there is a Utility Network Layer class. That matches up with the Utility Network layer that's on your map. It inherits from composite layers, so if you want to get to the dirty area and error sublayers that you see in the map, you can iterate through the children of the Utility Network layer. You can also get a utility network from that layer itself in one nice convenience method. Ribbon integration. So how many people here have written a custom add-in for Pro already? All right, so good, quite a few. You know that there is a config.daml file that's used to configure when your add-in is enabled, when your button is enabled. So we have a condition called Esri mapping utility network layer selected condition. And this will make your button become highlighted when the user has clicked on a utility network layer, a feature layer that corresponds to a layer that's in a utility network, and a subtype group layer, again, that corresponds to a feature class that is part of a utility network. Probably an easier way of saying this is that this works like the product. So for editor integration, the preferred way to do editing is to use a high-level edit operation class. So hopefully you guys had a chance to go to the editor SDK talk earlier this week. The way that class works is you create an operation, you make edits on that operation. So you create row, using this create method. You delete a row, you move a row, there's all sorts of different editing things you can do. All of those routines don't make the edits, they queue them up. And then you call execute, and that actually makes the edits, makes them happen, causes the service to be called, etc. So in 2.1, they extended that edit operation class to support some utility network editing. Namely, they've added new classes that allow you to create and delete associations. So again, not going to go through all the methods, but there's a connectivity association description, a containment association description, and a structural attachment association description. You set those things up with your features and terminals, and then you call create and delete overrides to create and delete those associations. So one interesting problem is that because you don't get the row created until you call execute, how do you create an association? How do you create features and an association between them in the same edit operation? Right? Because if you say create to create a poll and create to create a transformer, you don't have object IDs yet. How do you specify that you want to take that transformer and attach it to the poll? And the answer is we have new create EX methods on the edit operation that return what's called a row token. And you can think of a row token as this kind of an abstract class that represents an object ID to be named later. So you can then pass those into the association description classes. So what you can do is you say create EX to create your row, to create your pole, create EX to create your transformer, and then you call create with a structural attachment description to create that association, and you can do all three of those in a single edit operation. Worth pointing out that all that edit operation stuff, that is for any Pro add-in. There are, in addition, low-level geodatabase routines. If you are creating a standalone application using Pro's core host facility, this is the way you want to edit. You want to edit with these low-level geodatabase routines. Don't recommend doing them in Pro because Pro doesn't know anything about it. The map doesn't get refreshed. Undo, redo stack is not modified, and so forth. So we're going to have Dave give us some examples of how this editing works.
All right. So for the purpose of this, one of the things, so I'm going to show, first I'm going to show two quick editing samples. They're both very pro-centric editing samples. I'm going to walk through a core data one, but I'm not actually going to run it because the integration with map is not seamless. You have to do a lot of work to make that all function properly, but I'll at least walk through the code so you guys can see how it all would work if you were writing one of these headless apps. So to start with, I built myself a couple tools here. They're just basic sketch tools that I've overridden what they actually do. So if I first start with my create features using edit operations, so as Rich had described, so if I click on my map, you'll notice here in the on click or on the on mouse down, I've overridden what it actually does. And I go into this big method I have. And this big method, first off, I set up some global variables for myself just so that I can use them. Primarily what that is I'm just configuring layers into global variables so that each time I want to use them, I don't have to go and do the work to go find the layer I'm interested in, because you do have to iterate through all the map layers to find the specific one you're interested in. So in this case, I just store them once, use them as I go, and then rely on my effective use of the dispose method to get rid of them before I leave and go back to the app. So in this case, I create one of those edit operations. As Richard described, I give it a name. So I'm going to create 3 fuses inside a fuse bank, and because of a typo, I'm going to associated them, but I'm going to just associate them. So the way we do that is I grab the location where that user clicked, and that's the point where I'm going to create my fuse bank. Now, I am setting a Z value of 30. This would be the idea that it's hanging off a pole. I'm not going to create a pole in this example, but you easily could hook that in as well. The concepts are consistent across the board. What I do then is for that fuse bank that I'm interested in, there is an asset type that I want to set on it. Now, the asset type of 2 probably doesn't mean a whole heck of a lot to people. There is utility network APIs to go find out what those asset types are that you might want to use. And again, I'll show that in the core host version of this app. And then we go through, and as Rich had described, I'm going to pass in my fuse bank layer. I'm going to give it the geometry that I had just configured previously right here. And then I'm going to send in the attributes that are necessary to configure that fuse bank. And again, I use that create EX so that I get my token back. Because I know I'm going to, in one operation, create this fuse bank, create the fuses inside of it, and create the associations. I then do the same for each of the fuses that I'm going to create. So I'm going to create 3. So I just offset their locations a little bit so visually I'll be able to see them better in the map. And I offset their Z values as well as we go. I configure my attributes for each of them. So the A phase is a value of 4 in this case, the B is a value of 2, and the C is a value of 1, because it's a bit set. And then we go through, set our attributes, and we do the same functionality. For each of the fuses, we pass in the attributes we're interested in, the location where we want to build it, and the layer that we want to create it within. We can get those tokens back, and then we create row handles off of each of those tokens, which allow us to create these containment association descriptions. So I create a new containment association description where I pass in the fuse bank as my container, the fuse as my content, and this Boolean at the end is whether or not it's visible content. I have made it visible, so at the end of this demo, you can actually see it on the map. It may or may not be visible content depending on the use case you're using. And then I call create not EX, to create those association records. And again, as Richard said, if I had Fiddler open, you would have noticed that nothing has gone to the service yet. It isn't until this execute call that it goes to the service, that fires off, starts creating all those features, creates the associations, invalidates the layers in which they're created, and then draws it on the map. So if I zoom in here, you'll see that I have my fuse bank, my 3 fuses, as well as the dirty areas that represent the associations. If I look at the container itself, you can see it actually does contain those 3 fuses. Now that was a lot of work in the edit op, and in Pro there is such a thing as preset templates, which allow you to pre-configure something such as that, a fuse bank with fuses in it and containment. And the way we could handle that is, quite easily, we click in a new location, and what you'll notice, the first thing you'll notice is, as I look at the method, is that it is a much shorter method. And for this one, all I have to do is go get the layer I'm interested in, ask it for a feature template, which in my case is called fuse assembly with associations. So this is a preset template. I create that as a template, and then I can call create, passing in that template and the location where I want to create it, and then again call that execute async, and then it fires off, and the preset actually lays down all of those bits for me. So that's obviously an easier way when you're integrated directly with Pro to take advantage of some of that handy editing without having to write it all yourself. But you clearly can write it all yourself if you wanted to. And the last thing I'll show is sort of the core host version of this. So if I had gone in with the core host, I do the same sort of process. I tell it where to create these features, how to offset them, what the features are. So in this case, fuse bank, a couple fuses. The difference is, because I'm in a core host, I don't have layers to work with. So now I've got to work with the actual objects. I've got to open the utility network, get its definition, find the feature sources or the network sources that I want to create these features inside of. In my case, an assembly and a device. Grab those, go in there, find the asset groups that I want to create these features as, the asset types which are appropriate. Asset group will give you the asset type. Then I can go down, open the actual feature classes, because it's not enough to just work with the asset groups and asset types or the sources. You need the actual feature class. Then I can find my subtype that I want to create. And subtypes and asset groups are the same, but they're not directly castable to each other in this API. So you do have to go back to the feature class's definition, get your subtypes, and you can use an inline link query to just find the one that you're interested in based on the asset group's code. That asset group code is the subtype code. It's a one-to-one mapping. So in this case, it's pretty easy code to go and get it. We create row buffers in this world, which is where you define the shape and any other attributes you want to set on each of these feature types. And then we walk all the way down here, and in this apply edits call, we actually create the rows themselves in our assembly and in our device feature classes. Now, I have done this in an inefficient way because I call apply edits once to create the rows. I then create elements off of those rows. I then call apply edits a second time to create my associations. If we watched it in Fiddler, it would be 2 completely separate apply edits calls. I could bundle it up all into one. I just occasionally like to show people how to not do things so that then they remember, maybe I shouldn't do that. And in this case, at the end of it, I have to call redraw map. But the truth is, even this redraw map won't work fully to refresh your map. You'd actually have to invalidate layers, which is because I'm interacting with Pro, but I'm using a core host app, I have to call a bunch of other edit operation type methods to make it work properly. And those are the ways that you can edit this stuff through code.
Thank you, Dave. All right, let's wrap up with a couple of things to look out for in Pro 2.1, also known as the things that Rich screwed up. Some utility network operations are not that well integrated into Pro. The low-level stuff, the core.data routines, are all great, but they don't always hook up to core desktop properly. And I'll go through a couple of examples there. Some functionality is missing in the first release. So some of the things that don't work all that well, if you call validate network topology directly, you cannot be in an edit session, it doesn't work with the undo redo stack, and it doesn't redraw the screen. So the workaround in this case is use geoprocessing in the first release to validate your network topology. Enable and disable controller, they don't integrate with the Pro undo redo stack. They don't redraw the screen, and unfortunately there's no GP tool for these, so for the first release, if you call these routines, you're going to have to see some funny things. And finally, update subnetwork does not redraw the screen. Again, the workaround there is to use geoprocessing. Some of the things that we did not put in the first release, tier groups, terminal paths, and attribute rules. Now, attribute rules are not supported in C#. It's just that we will eventually provide schema classes that will give you read-only access to what rules are assigned. The view association tool that you click on the map and it draws those associations on the screen, that also is not available through C#. And finally, there's some other things on subnetworks. You can't update all subnetworks in one call. You have to go through a loop, calling update on each one. So plans for 2.2 are to fix the mistakes and do some better integration. So in particular, we've added utility network extension methods. So if you're familiar with the C# extension method, you add a new using statement. There it is there, utility network.extensions. And that appears to add methods to existing C# classes. So it looks like you went down and changed core data, but in fact, the routine itself is still at that high-level workspace. So we have a validate network topology in edit operation call. If you do that, it will redraw the screen and do the edit operation correctly. And there's enable controller and disable controller in edit operation, again, completely integrated in. Finally, we got the map team to add a redraw method to redraw the whole map so that after you call update subnetwork can do so many different things for labeling and your subnet line. It's easier just to refresh the whole screen. It's already an expensive operation. So that stuff, there's a little slightly green check box there. That is all in 2.2. It's been tested, it's installed, it's ready to go. As close to a guarantee as I can give you that it will be in 2.2. We are going to be working on some of this stuff. These are works in progress. They're currently listed in the priority that I think is correct. If you disagree, let us know. We can maybe juggle some things around. And we're certainly not going to get to all of these in 2.2. So they're a work in progress that we hope to have there, if not 2.2, in 2.3. Finally, I know we're running a little low on time. And to give you a whirlwind tour of what documentation is available. If you go back to that home page I talked about, the very first slide, you can click on Utility Network, and then you can see the full conceptual doc. This is pages and pages and pages covering all the material in this talk and a whole lot more. Lots of details. If you click on the samples link on that sidebar, you can go to a set of utility network samples. So currently we have two. One of them is called category usage. It demonstrates how to use the schema classes. In this case, it allows you to get all the asset types for a given category. There's a load report sample that goes through code very similar to what we showed at the plenary of doing a trace and doing some calculations. So two more that we're working on for this fall, placing a transformer bank that's going to be similar to what Dave just showed us, and a custom network diagram layout, again, similar to what Dave showed us, targeting those for the spring. If you have suggestions, if you have things that you would like to see us do, let us know. We have a big list, but we're glad to put yours at the top of the list if it makes sense. And finally, this is a GitHub site. This is a community site. If you want to write your own sample and kind of demonstrate to the world that you know the utility network, you can issue a pull request, I believe is how you do it. Another link on that concepts page brings you to a page called Pro Snippets. We provide small pieces of code that let you accomplish specific tasks. So you can just, in some cases, just copy and paste this code into your own app. So, for example, get a utility network from a table or get it from a layer, little things like that that you might find useful. Going back to the Pro big page, API reference, that's definitely something you want to keep bookmarked. This gives you a list of all the classes and all the methods available throughout the entire Pro SDK. And finally, exclusive to Utility Network. This gray hair isn't because I work at Esri, it's because I'm old, and I'm old school. So, remember those nice COM diagrams you used to see back in the day? Well, here's your E-size plot of the Utility Network API. All right. That is the only thing. That's great. I'm glad I built it. We are out of time. Question?
What's the logic, or why create EX versus chain edit operations?
Why create EX versus chained edit operations? I believe even a chained edit operation creates multiple transactions. I'm not sure. That would be something that the editor team built for us. Good question, though.
Could you talk more about the licensing?
Can we talk more about
Can we
licensing?
talk more about licensing?
No.
Yeah, not really.
I can handle that question.
Okay.
In regards to licensing, you're going to want to contact your sales team because the licensing is still kind of a work in progress. So the best answer you're going to get is from your sales rep.
The technical answer is that this is licensed on the server side. It's the Utility Network Management extension, so you don't need to do any checking out of licenses in your client code.
In tracing, I know in previous products when we were like trying to compare like between versions, looking for edit deltas, right? You can see all the attribute edits, new objects, removed objects. But in the old model, if say a network, someone disconnected something, but it was not actually moved, it was not visible, right? So the idea of looking at two versions, did anything change from a tracing perspective, right? Geometry is the same. In the new Esri model, will you be able to compare two versions and say, hey, look at this, a couple attributes have changed, and a person changed it's no longer connected. Geometry is the same.
Right.
Is that visible?
So the question is can you compare? Can you use tracing to compare two versions and to see the changes? Back in the old geometric network days, you could take two features that are connected and you could call disconnect on them. And although they appeared to be, they were disconnected, but you couldn't see the change in.
Between the two versions.
Right.
So you'd actually have to do a trace and
Right.
visually look at it and go, that was nuts. You couldn't figure out what changed.
The short answer is there's no way to disconnect two features that are geometrically coincident
In this model.
in the utility
Yeah.
network.
So it can't happen. That error is gone. Then.
Correct.
Yeah.
Yep. All right. One more. The question is, are any of these calls asynchronous? No, they're currently all synchronous. We may look at providing SDK access to some of the asynchronous REST calls in the future. All right. Thank you all for coming. Enjoy, and make sure to go